Arete, Autonomous Robotics Empowering Technology Through Ethical AI, is a distributed system on a team of autonomous robots working together to gain situational awareness. Arete operates at the tactical edge, in GPS-denied environments, and without an external supervisor. Alongside the use of cameras and sensors to gather real-time data, our AI technologies and custom frameworks bring the possibility of situational awareness to life. The framework for Arete runs as a decentralized and distributed system solely on top of the robots, for instance our air units, HERA, removing the need for communication with an external supervisor. This framework does not provide any functions for a specific use case but provides the capability of communication between these units working as a team to achieve the goals of such a particular use case. This allows for utilization of Arete with other use cases that could also require different units. The framework for HERA's drones gives the functionality for aiding in search and rescue. Joining forces with Arete, each drone maintains and shares all of the information needed to execute an efficient search and rescue scenario. This includes the data acquired from scanning an unknown area and the position of other drones or units in order to compute and delegate areas still needing to be searched. While searching, these units are gathering the data to recreate the scanned environment as a 3D map. These 3D maps are essential in disastrous situations where assessment of the environment is needed in order to make a safe rescue. The framework provides the ability to recognize a terrain type through image recognition, so that the area of interest needing to be searched can be provided as a boundary with a description. For example, to scan forests with fallen trees or other infrastructure within a given sized area. This allows the area of interest to be narrowed down dynamically during flight to places relevant for the particular mission. Not only is this beneficial in situations where the area is unknown, but is also beneficial for battery optimization. Furthermore, the framework gives the units the ability to dynamically attach or detach from the team at any time or place in order to recharge or return data to a ground station if a large-scale search area is required. In search and rescue, drones can save resources that are typically spent on manned helicopters or first responders having to put themselves in unknown and potentially unsafe situations. A team of drones efficiently scanning an area can be substantially faster than these traditional methods, which ultimately improves victim survival rates. Their small size, relative to helicopters and people, gives them the ability to provide a safe, close-up view and assessment of the environment. The Federal Emergency Management Agency, FEMA, defines 4 phases of disaster management: mitigation, preparedness, response, and recovery. According to the global study Remote Sensing of Environment that was conducted by the University of Calgary from over 600 scientific case studies, 87% of these studies were focused on the use of drones for the mitigation and recovery phases. Drone-based support in these phases can include vulnerability assessment, risk modeling, damage assessment, and infrastructure or environment recovery. The response phase would include search and rescue, rapid damage assessment, and temporary clearance of debris. HERA drones have the ability to gather real-time data at the tactical edge, which is an important tool for this response phase. With yearly economic loss close to $190 billion, search and rescue and other response-related applications are a vital component of disaster management. Utilizing drones to their maximum potential is an innovative and likely life-saving approach.